Okay, we are proceeding with our topic here, which is approximation. This is the second part. We are going to pass through approximations in calculation. Approximations in calculation. Okay, we say that in calculation, it is useful to find a rough estimate of the answer. Then we say that to carry out a quick check of all calculation, we are taking the suitable approximation by rounding off the numbers involved. So the concept of approximation in a calculation, we find a rough estimate by rounding off the numbers involved. First, before doing any calculation, you have to round off the numbers involved first. Then we say that uh, the sign used for approximation is that one. This is a sign which is used for approximation. Okay, now let us see example 1. We have given that estimate the value of 521 times 29. But you have to be very careful. The concept here, you have to estimate. The term estimate mean that you have to find the rough estimation of the answer. The rough estimation of the answer. Okay, here we have 521 times 29. Mean that according to this approximation in calculation, we have to round off the numbers involved first. You have to round off the number involved first. Mean that this 521, this one will be approximated to 500. Mean that the highest place order here is this is ones, tens, hundreds. Then we round this number to hundreds, the highest place order. Mean that this one will be 5. Digit to the right is 2. Mean that it's below 5. So mean that this one will remain unchanged. The rest will be replaced by 0, from which this is approximated to 500. Then we have this 29. 29, the highest order, ones, tens. The highest order is tens. Mean that we round it to tens. Digit to the right is exactly 9. So mean that 1 will be added, from which you get 30. Then from there, after rounding the numbers involved, then we are doing the calculation. So this is simply 521 times 29. This will be estimated as 500 times 30, from which you get 15,000. That is the concept. So you have to be very, very careful on that. Okay, now let us see second example. Second example, we are required to estimate 38 times 71. 38 times 71. Okay, the procedure is the same. We have to round off the individual or the numbers involved. Okay, this 38 is approximated to 40. Mean that the highest place value is tens. This is ones, this is tens. Mean that we are rounding those numbers to the highest place value. Okay, to round this 38 to tens, digit to the right is exactly 8. Mean that 1 will be added, from which you get 40. Okay, then you have this 71. The highest place value is tens. Mean that the digit to the right is 1, so it will remain unchanged, but you replace this by 0. This will be 70. So 38 times 71 will be estimated as 40 times 70, from which you get 208. From which you get 208. That is second example. Now let us see example 3. We are going to estimate the value of 8,280 divided by 38. I mean that you have to find the rough estimate of the number involved. Okay, I mean that I have given that 8,280 divided by 38. I mean that you have to round the number involved. This 8,000 is rounded to 8,000. Mean that because this digit to the right is 2, mean that it will remain unchanged. The same to this one, the highest place value is tens. Mean that 1 will be added, from which you get 40. So if you divide there, you get 200. That's the concept. Okay, now we are proceeding with the term of significant figures. We are proceeding with significant figures. We say that any digit from 1 to 9 appearing in a number is a significant figure. Mean that 1 to 9, those numbers appearing in whatever numbers, we call that they are significant figure. Then we say that each zeros between digits from 1 to 9 is a significant figure, mean that also zeros which appear to the number between 1 to 9, they are also significant figure. Okay, take example. For example, the 0 in 602 is a significant figure, mean that here we have 3 significant figure. 6 is a significant figure. Also this 0, because it occur between 6 and 2, mean that also it is a significant figure, and also this 2 is a significant figure. So there we have 3 significant figure. Then another case we say that when the zeros are written to the right of the last non-zero digit of an exact number, the zeros are not significant figure. Take example, for instance, this 72. Then you have 0, 0, 0. We don't have any number which is ranging from 1 to 9 after these zeros. Mean that these zeros, they are not significant figures. So this 72,000 has only 2 significant figures. So you have to be very, very careful on that condition. Then we say that in decimals, any zeros to the left of the first non-zero digit is not a significant figure. For example, the zeros in 0.025 are not a significant figure. Mean that those zeros written before the non-zero digits on decimal places at the left, 0 and 0, these are not a significant figure. But if it could be the number there, then 0 exists between, they would be a significant figure. But those zeros written to the left of the first non-zero digits, they are not a significant figure. So here we have 2 significant figure. Then you say that when 0 is written at the end of an approximate decimal or number, it is a significant figure. Another rule states that when the 0 is written at the end of an approximate decimal or number, it is a significant figure. Hold the meaning behind. We say that when you talk about approximate decimal or a number, it means a decimal or a number which has been rounded off to either tens, either ones, hundreds, etc. That 0 will be counted as a significant figure. Take example. For instance, 2.74. If this one is rounded to ones, mean that the required position in this one digit to the right is 7, mean that 1 will be added, from which you get 3.0. This 0 will be counted as a significant figure because it is written at the end of approximate decimal or approximate number. Okay, let's see another example. We have this one, 45961. If this one is approximated to hundreds, mean that this is the ones, tens, hundreds. This one. So the digit to the right is 60. Digit to the right is 60. Digit to the right is 60. So you can see that if 1 will be added, if you add 1 there, it will be 0. Then here it will be 60. From you get 46, 0, 0, 0. Okay, this zeros which is written at the end of approximated number is a significant figure. So simply we say that the 0 at the third place value is a significant figure. That is, we have that is the 3. We have from that number we have 3 significant figure. I mean that 4 is a significant figure, 6 is a significant figure, and this 0 is a significant figure, but not this one. So you have to be very, very, very careful to that rule. Okay, now let us see some examples. We have given, write the number, this one correct 2. One significant figure, 2, 4, and 5. Okay, this number, first of all, you have to know how many significant figures are there. We have 1, 2, 3, 4, 5, 6. So we have 6 significant figure. Then we are required to write it to 1 significant figure. Okay, 1 significant figure means that it will be this 8. Digit to the right is below 5. So the rest will be replaced by 0. So it will be 80, 0, 0, 0. So this is a 1 significant figure because these zeros are not counted as a significant figure. So you have to be very, very careful on that. B, 2 significant figure. 1, 2. Digit to the right is 5, means that 1 will be added, from which you get 85. The rest are replaced by 0. So it will be 0, 0, 0, 0. So this is 2 significant figure. And then 4 significant figure. We count 1, 2, 3, 4. This one. Digit to the right is 6. Mean that 1 will be added. If 1 will be added, here it will be 0, here it will be 6. So it will be 8, 4, 6, 0. This 0, according to the last rule, it will be counted as a significant figure. So there we have 4 significant figure. The last one is 5 significant figure. We have to count 1, 2, 3, 4, 5. Digit to the right is 1, mean that it will remain unchanged. So it will be 84, 5, 9, 60, 0. So these are the 5 significant figure. Okay, now let us see another example we have given. Write the number 0.064682 correct to A, one significant figure. These zeros are not a significant figure, mean that the first significant figure is 6. Digit to the right is 4, mean that it is below 5. So to one significant figure, it will be equals to 0.06. Others are dropped. Then we have 2 significant figure. We have to count 1, 2. Digit to the right is 6. 1 will be added, so it will be 0.065. Then 3 significant figure. 1, 2, 3. Digit to the right is 8. 1 will be added, so it will be 0.0647. Then we have 4 significant figure. We have to count 1, 2, 3, 4. Digit to the right is 2, mean that it will remain unchanged. So 4 significant figure to be equals to 0.06468. Okay, example 3. Determine the number of significant figures. For instance, this one. We have 1, 2. These zeros are significant figures. So the number of significant figures there will be 1, 2, 3, 4, 5. So there we have 5 significant figures. Here we have 3, mean that 8, 0, and 4, they are significant figures. So we have 3 significant figure. Here we have only 1 significant figure, these 2, because these zeros are not counted as a significant figure. So we have 1 significant figure. This one we have 4, mean that 1, 2, 3, 4. These are not significant figure. So we have almost 4 significant figure. Okay, now let us see another party which we call it decimal places. We say that all positions occupied by digits to the right of the decimal point are the decimal places of a number. For example, 7.2 has 1 decimal place. It means that all positions occupied by digits. When you talk about digits, we mean 0 up to 9. That are the digits. So I mean that even 0 is included as the party of decimal places. So here we have 1 decimal places because we said that all positions occupied by the digits to the right of the decimal point. Mean that after decimal point, the first digit is the decimal place. Here we have 2 decimal places. Here we have 3 decimal places. Here you have 0 decimal places because we don't have the decimal point. So we have 0 decimal places. Here we have 4. 1, 2, 3, 4 decimal places. Okay. Now let us see how can we write numbers to the required decimal places. How can we write numbers to the required decimal places? Okay. We say that take the case of writing a number to 3 decimal places. Then in that case, consider the 4th digit after the decimal point. If the digit at the 4th decimal is less than 5, then the digit at the 3rd place will remain unchanged, and all the digits after that will be dropped. For example, 8.126347. This will be equals to 8.1263 to 3 decimal places. You have to count 1, 2, 3. Digit to the 4th digit is 3. Mean that it is less than 5. So it will remain unchanged and the rest will be dropped. So it will remain 8.126. Okay, we shall end there. The next time we shall proceed with another rule so as to accomplish this party, the last part of the approximation. Thank you very much. Have a nice time. Next time we shall proceed with another remaining part. Thank you so much.